Okay, year 11, our final exercise for the term, and it's this intersection of graphs. And I have a bit of a problem with this, solving equations graphically, because I believe you can really, without technology, really only do linear. I think it's very hard to do cubics, quadratics, and further ones. So let's go and have a look at the maths syllabus to see what they say. So I downloaded the maths syllabus, and it's probably a good time to have a look at this and go over some of the things to make sure that we can answer all the questions. So we've been doing functions, and we've been doing linear, quadratic, cubic, and polynomials. So let's see what they have to say about that. So just making sure you can do all these different things and that all these words you're okay with, all this terminology. So model, analyze, solve problems involving linear functions. Pretty sure we can do that. The direct variation, and that's important. So the direct variation in relationships that produce a straight line graph. Y equals m, or f of x equals mx plus c. Our gradient point form, y minus y1 equals m outside of x minus x1. Finding straight lines, finding parallel lines have the same gradient, and perpendicular lines multiplied by each other, the gradients multiplied by each other to give -1. With quadratics, which we spent a lot of time on, knowing the features or recognizing the features of a quadratic, its turning point, the axis of symmetry, the intercepts, vertex and the intercepts, and graph a quadratic function by either factorising, completing the square, or solving the quadratic equation. Know what the discriminant is and find the equation. Now, this is an important one. Find the equation of a quadratic given sufficient information. And that was that exercise, I think it was 411 or 412, where they gave us 3 points. And there's been a lot of discussion about that amongst teachers throughout New South Wales about what that actually means. But hopefully that'll become clear as this year's HSC sits, in case they have any there. So now this is the point that we get to now. So solve practical problems, and the big emphasis here, practical problems involving a pair of simultaneous linear and/or quadratic functions. Now, and algebraically, so be able to do that algebraically and graphically, with or without the aid of technology, including determining, and this is a big one, the break-even point of a simple business problem. And here, understand that solving f of x equals k corresponds to the values of x for which the graph y equals f of x cuts out line y equals k. So that's what we're going to be doing today. Before we move on though, let's have a quick look. There's the cubic, and notice that you get k x minus b cubed plus c. That was a form that we were given. And f of x equals k times x minus a, x minus b, x minus c, where a, b, c and k are constants. And we can graph that. So that was what that cubic was about. Over here, further functions, which we're going to do later. In our textbook, we've already done polynomials. And you can see here the first dot point the first couple of dot points goes through defining a real polynomial, and we did that in the previous one, identifying the coefficients and degree, identify the shape, the graph, recognize the function, and sketch their graphs. So those first 3 dot points deal with what we did in the exercise previous. But let's go back to here. Solve practical problems involving a pair of simultaneous linear and/or quadratic. So we don't need to go into cubics. And it's practical. So these have got to be practical. So the first couple in this exercise are just going to be straight out solve these functions. But the first wording here is practical. So we'll have to see what sort of quadratic ones they give us. Linear ones are quite easy. Now, to do this, you're going to need graph paper, or you're going to have to use Desmos or some form of technology. It does, however, say with and without, so we need to do both. So let's go and have a look. So to solve these problems, we need to be able to draw them. So the first one, and if you go to our website, I've done these very accurately. There are photos on the board right up to question 8. So there are only 11 questions in here. So you can see how I did them on the board work. So to do this one, I'm going to quickly do the first one, and I'm going to do it here freehand, which is going to be very hard because even though I can get this here, I can't graph it as accurately. So first of all, I want to graph this function, f of x equals 2x minus 4. Well, that's just y equals 2x minus 4, which means it's going to go through minus 4, 2, 3, minus 4. And it's got a gradient of 2, which is pretty steep. And when x equals 0, let's find that. So f of x equals 2x minus 4. When f of x equals 0, we get 0 equals 2x minus 4, and I take 4 over, equals 2x, and I get 2 equals x. Now that's the x-intercept. So 1, 2. So now I'm going to draw this line. And it's going to be very hard. Actually, I might be able to do it if I do, here we go. Okay, and that'll have to do. Now, this is minus 4, and this is 2. To find graphically f of x equals 0, you're just looking at this line here. And there it is. And we already did it algebraically. But what about f of x equals minus 2? Well, then what I have to do, and again, I'm going to try this, I have to draw a line through minus 2. And now I have to try and interpret this coordinate. And for me, that looks like 1. Right? And remember, this is very hard because I don't have grid paper, but I'm pretty sure that the solution to that will be 1. Let's do it algebraically. So if f of x equals minus 2, so minus 2 equals 2x minus 4, take the 4 over 2, 2x equals 2, divide by the 2, and you get x equals 1. So even though I've done this pretty without a ruler, it's come out pretty well. What about f of x equals 4? Well, now that means I just have to draw the line y equals 4. So I'm going to go 1, 2, 3, 4. I'm going to have a bit of trouble here. And I draw this line. I'll move it down a bit. Can I move it down? I can't. I'll undo that and undo that. So try again. So it's going to be approximately there. Now what will that value be? 3. We saying a guess at 4? And that's what I mean. You're trying to find where it cuts. So let's do it algebraically. F of x equals 4. So 4 equals 2x minus 4. Take the 4 over. 8 equals 2x. 4 equals x. So yeah, pretty much on 4. So that's how you're meant to do those without technology. And if you use a ruler and you use graph paper, linear ones are pretty easy. But doing these ones, f of x squared minus 2x graphically, that's going to be really hard. So I'm going to have a go at it graphically, and I have done it on the board work, which is on our website. But what I'm going to do to double check this is I'm going to solve it algebraically, and I'm going to use Desmos. So first of all, let's get ourselves this, and let's graph the parabola. Now y equals x squared minus 2x. Well, x squared minus 2x, first of all I need to have some things. If I've got f of x equals x squared minus 2x, it's a positive parabola. Let's put it equal to 0. I can find the vertex, but watch, I'm going to find the roots and it's going to be really quick. X squared minus 2x, therefore 0 equals x outside of x minus 2, which means the roots are at x equals 0 and x equals 2. So my roots are here, 1, 2. That's probably a bit far. As I said, it's going to be hard, so 2. So I've got a root there and a root there. The vertex is halfway between the roots, so the vertex is going to be 1, but let's show it. The vertex is going to be when x equals minus b on 2a, so it's minus minus 2 on 2 times 1, which is 1. So my vertex, and when x equals 1, f of 1 equals 1 squared minus 2 times 1, which is negative 1. Okay, so the vertex is down here. There we go. So now I've sort of got to get this parabola, which is going to be very hard to hit these 3 points. And there's my guess at y equals x squared minus 2x. Now, I've got to find 0. Well, 0 is just this axis, and we've already found that because we factorised. So the solution to the first part, f of x equals 0, we get x equals 0 and x equals 2. F of x equals 3. Now this is going to be harder. 1, 2, 3. We have to draw a line through there. So, too big. Come on, undo that. Let's try again. There we go. And again, I'm going to have 2 solutions. And they're going to be here and here. Now, if I go down here and find this point, that looks like it's going to be 3. And this one looks like it's going to be minus 1. That'd be my guess. So now let's do it properly. Let's use Desmos. So with Desmos, we'll go up here and we'll plot y equals x squared minus 2x. And there it is. And then underneath, I'm going to draw y equals 3. And you can see straight away, you get these points. And it's 3, 3, and minus 1, 3. So my graph was pretty accurate. But it's not a really good system to use for quadratics. You can do it with linear, but quadratics, it's really hard. And you know when we were sketching cubics, how far and away ours were from the real thing when we did them. All right. So this is just going to be solving these again. Don't do this one. All right. Here they've got a cubic in there. I'd rather you do that technology, we're using technology, do it on Desmos. The main ones you have to do are ones like this and these quadratics. But I'm going to do one that has a break-even point. And I'm going to do question 8 because it's on the website. So here we go. Question 8. So we've got two equations. So Paula's posies come in y equals 10x, where x is the number of roses, and that's the income. I'd rather have I equals 10x, but anyway. And the costs are y equals 3x plus 980. Now let's examine that a bit. So the cost is 3x, where x is the number of roses. So if there was one rose, the income would be 10 times 1, $10. If there were 2 roses, 10 times 2, $20. So this income is going to have a gradient of 10, and it's be a straight line up, and that's the income that Paula's Posies makes from selling roses. However, the costs is 3x plus 980. Now, what does that represent? Well, the 980 are startup costs. It could be the cost of renting, and I don't know whether this is a daily or weekly cost. It could be the cost of the rent, the cost of utilities, the cost of wages, the cost of time. But the actual cost of sourcing the roses is $3 because it's 3x. So you need to understand what these things mean. Let's now draw, hold on. Let's get myself an axis, and this time we only want, come on, come down. We only want the positive. Now, in this case, I'm going to have a different scale. All right, I'm going to have a different scale. So this is my y-axis and this is my x-axis. However, this is income and costs. It could be considered the dollars. So let's graph 10x. And along here, I'm just going to go up in hundreds. 100 roses. This is the number of roses. Number of roses. 200, 300, 400. And remember, I'm doing this by hand, 500. Whereas along here, I'm going to go up in thousands. 1,000, 2,000, 3,000, and I'm doing this by hand, 4,000, and I'm doing it this way because this is how it is on the picture on the website. Okay, now the first one, 10x. So if I sold 100, I get 10 times 100, 10,000. Oh, sorry, 1,000. So that works really easy because there's my first point. And if I sold, if I sold 200, I get 2,000. So this straight line, and I'm going to keep it in red, it's going up like that. And that is y equals 10x. Remember, I've got a different scale on each axis. Now, my costs are 980. So I'm going to have a little guess. 980 there. And to work out these costs, I'm going to have to plot some points. Now, I only need to plot one. So let's find out if I sell 100 roses. Well, 3 times 100 plus 980. 300 plus 980 is 1,280. So 1,280 is about, I don't know, there. Now, I'm going to do another point, even though I don't need to. I'm going to go 200. 3 times 200 plus 980 is 600 plus 980, and that gives me 1,580. So 300 is 1,580. So immediately, it's about, I don't know, there. And straight away you can see I haven't even got a straight line, but I'm going to do the best I can. And I'll just, make that bigger. It's always a hint. You can always make the points bigger. Now, that's my cost, and that's y equals 3x plus 980. Now, this is the crucial bit, this bit here. This is the break-even point. This is where you break even with your money. So at Pete's Pansies, Posies, Paula's Posies, if Paula doesn't sell more than that amount of roses on the x-axis, if she sells less than that, she's going to lose money because her costs are above her income. After that point, after she sells what looks to me like 150 roses, she's going to start making a profit. And that's a break-even point. So that's really important to understand, that this point here is the break-even point. And this area in here is profit. And this area in here is a loss. Okay, so let's do it properly. Oh, hold on, let's use our graph. What was the questions? Find the profit. Now you meant to do this, great. So what did we say the break-even point is? Well, I think here, the break-even point is 150 roses, graphically. X equals 150 roses. I'm going to do it algebraically. I'm going to do it on Desmos to see. Find the profit on 189 roses. Okay, so the profit on 189 roses. Can you see how difficult this would be? You go on 189, it's really hard to work out. But you've got the two formulas here. So the profit, so this is, we found one. That was one, wasn't it? A, so this is B. If X equals 189, the profit will equal 10x, that's the income, minus, and you've got to be careful here, 3x plus 980. So 10 times 189, that's your income, minus 3 times 189 plus 980. Okay, so I pull out my calculator because I'm not doing that one in my head. 10 times 189 minus bracket 3 times 189 plus 980. $343. And I'm just going to get the answers up. Yep. Now the other one, the last question said, find the loss on 45 roses. So I'm going to do the same thing. C, X equals 45. Now all I've got to remember is this is going to come out as a negative number. So the profit equals 10 times 45 minus 3 times 45 plus 980. And I'm going to put that into my calculator. I'm just going to go back and change that to 45. Change that to 45. Negative 665. So negative 665. So a loss of $665. Now, if you use Desmos for this, let's have a look at what they were again. 10x and y equals 3x plus 980. Now, we have to bring it right in because we need a different scale. And you can see, because they've kept an even scale on both sides, they're going up by 500s. Now, let's hit it and see that what's that break even point? 140. Right, now and if you go back here, I find it hard that you're going to have to be very accurate with that to get it. All right? And using my terrible graph, I was just guessing. I was in the right ballpark, but I wasn't correct. And then you can just find the other points when x equals, using technology, you can just put them in and see what they are, so you can go along and find out what those ones are. There is another way to do it though. If you want to find the break-even point, you can solve simultaneously. So what do we got? And we'll use the y. Y equals 10x and y equals 3x plus 980. We'll call that equation number 1. We'll call this equation number 2. And I'm going to sub 1 into 2, which means, come on, everywhere there is a y, I'm going to put 10x. I'm going to put 10x there. So 10x equals 3x plus 980. Come on, move. Thank you. Minus 3x, 7x equals 980. And divide by 7. So 980 divided by 7, 140, which is the correct answer. So finding the break-even point by solving simultaneously. And you can find out the y value of that. So y equals 10 times 140. So we're subbing into equation number 1. We get 1,400. All right. That's where the costs and the income are exactly the same. So when Paula sells 140 roses, she gets 1,400 and it costs her 1,400. All right, you need to have a go at those. This is the last exercise before the term finishes. So have a go at them. I really stress doing these ones because that's where I reckon you're going to get them. The direct proportion just means that there's a constant. If you have a trouble with that, give me an email and I'll do another video. Good luck.